Welcome back to 3 Inquisitive Kids. In this video, I would like to share with you a very interesting problem I found. Here's the problem. X is greater than 0. What is the maximum, I'm not going to write value, what is the maximum value of x over x plus 1 squared? And we know that x is a real number. I'm going to share with you two solutions. So let's start with the first one. The first solution is pretty clever. If we're trying to find the maximum value of this, isn't it the same thing as finding the minimum value of its reciprocal? So it means now we're trying to find the minimum of x plus 1 squared over x. They are each reciprocals. So let's do this. We can first try to expand the top, and we're going to get x squared plus 2x plus 1 over x. So here's something you need to know. If we have a minus b squared, this value has to be greater or equal to 0 because it's a square. So if we expand it to get a quadratic function, like this, it's still greater or equal to 0. And we can move this negative 2ab to the right to get a squared plus b squared is greater or equal to 2ab. This is very important information you need to know if we're going to be solving hard problems with quadratic functions. This final conclusion, a squared plus b squared is greater or equal to 2ab, is very important to remember. So then how can we apply this to our original problem? Well, in this case, we can first divide the x into the top numerator. So we're going to get x. This is equal to x plus 2 plus 1 over x. And in this case, the x is the a squared, the 2 is the 2ab, and the 1 over x is equal to the b squared, if we're looking at a quadratic function over here. So then, using what we just proved, a squared plus b squared is greater or equal to 2ab, we can use that on our original problem. So in this case, a squared is x plus b squared, 1 over x, is greater or equal to 2 times a, which is square root of x, times b, which is square root of 1 over x. Now that we have this, we can continue to simplify. 1 plus 1 over x is greater or equal to 2 times x over x. This is the same thing as x plus 1 over x is greater or equal to 2. And now, because we want to get back into a form of this original quadratic, let's add a 2 back on both sides. So we have x plus 2 plus 1 over x is greater or equal to 4. And now, when we zoom out and we look back, we see that over here, the x plus 2 plus 1 over x, we derived it from this, and we derived this from this original fraction, which means that we can go ahead and write x plus 1 squared over x is greater or equal to 4, because these two are the same. This tells us that the minimum value of x plus 1 squared over x is 4. But when we go back to the original question, it says the max of its reciprocal. So then all we have to do is a little bit of flipping, and we get our final answer, which is x over x plus 1 squared is less or equal to 1/4. Which means that the greatest value x over x plus 1 squared can be is 1/4. So here is our answer. That solution I just showed you was one solution, but we have another solution that uses what we know about the discriminant. So let me rewrite the question. X is greater than 0, and what is the maximum value of x over x plus 1 squared? And x is a real number. We can let y, which is one variable, to equal what we're trying to find. This basically helps us look at what we're trying to find as a whole. And then now we can go ahead and multiply y times x plus 1 squared on both sides. So we get this. And then we can expand the x plus 1 squared to get y times x squared plus 2x plus 1 is equal to x. And then we distribute the y into here to get yx squared plus 2yx plus y equals x. Now let's turn this into a quadratic function that we're familiar with, which means that we want the right side to be 0. So then we subtract x on both sides. So we have yx squared plus 2yx minus that x plus y. And then because we subtracted x on both sides, we get a 0 on the right. Now we can change this up a little bit to get it to be yx squared plus, let's just factor out the x, 2y minus 1x plus y equals 0. Now this format looks very, very familiar. We could go ahead and put y as our a. This 2y minus 1 can be our b, and this y can be our c. And now we're going to use what we know about the discriminant. The discriminant is a part of what you learned about quadratic functions. So then, according to the discriminant, we know that b squared minus 4ac is greater or equal to 0. If you don't remember this or you don't feel like you're really comfortable with this yet, you better go back and review what you learned about quadratics, because this inequality is very, very important in solving problems in the future. So we know this, and we could go ahead and apply it to our own problem. B squared is the 2y minus 1 squared minus 4 times a times c, which is 2y, so y squared, is greater or equal to 0. We can expand the 2y minus 1 squared to get 4y squared minus 4y plus 1 minus 4y squared is greater or equal to 0. And then these two 4y squares cancel each other out. So we have 1 minus 4y is greater or equal to 0. So then let's add 4y on both sides, and then subtract both sides by 4, and flip this inequality a little bit. So we have y is less or equal to 1/4. And what does y equal again? In the very beginning, we let y equal x over x plus 1 squared. So then x plus 1 squared is less or equal to 1/4. This means that the greatest value this can be is 1/4. So our answer, again, is the same thing as our previous solution, is 1/4. Now let me just move this solution to the side of the previous solution so we can compare it a little bit. So pause the video, take a second to take in these two solutions. I hope you learned something from this video, and I hope it inspired you to want to solve quadratic equations at a whole different level. Because using the basic concepts we know about the discriminant and reciprocals, we can do so much more with them. Thanks for watching, and I'll see you in the next video.